My microphone is muted. I don't know why. Right, Khalef, please. Can you read?
Are used in cameras to make sure the image is sharp. They're also used in microscopes to make small things look bigger, and in telescopes to make distant objects look closer. Many people wear spectacles with lenses to help them to see more clearly, and lenses are used in theaters to focus beams of light from spotlights.
What are spectacles? Anyone? Spectacles, they're glasses. So lenses, they're used to make things look bigger, look closer, more clearly, and focus. Okay? This is just quick revision, guys, because you should know this from last lesson that you did yourselves. Let's have a quick look at this video. Anyone know what this? Anyone know what this is?
A lens.
Microscope.
Yes,
Microscope again.
Magnifying glass.
Thank you. Magnifying glass. Can someone tell me if they can hear the audio of the video?
No, we can't.
No?
We don't hear, Mr.
Okay, I'll just tell you what they're saying. So not just magnifying glasses, lenses are used in microscope and telescope. And that helps science a lot. This is a microorganism, a single-celled organism called amoeba. It's extremely small. It's too small to see without a microscope. So we can see using microscopes how the amoeba moves and how it's constantly changing its body. So we can actually see the chemical reactions that are happening in the cell with these type of microscopes. So pharmaceutical companies or companies that make medicine can see whether their medicines kill cancer cells within the body by using these microscopes. So you can actually attach these live cells with this fluorescent highlighted green color. So if the cells die, then they no longer are that color. The way the cancer drugs work, they stop the cancer cells growing very, very fast and dividing further. So that's how the cancer drugs work, and lenses help us to see what's going on. Galileo, an Italian astronomer, a very long time ago, he made the first telescope over 400 years ago. So Galileo's telescope was a tube that contained two lenses. So he could see the planets and the moon. So his telescope could obviously show more detail than people could actually see using their eyes. So what he thought was that the dark spots on the moon were shadows from mountains. So this image of the moon is from a modern telescope. So with his telescope, he actually discovered the 4 largest moons of Jupiter, I believe. And then they just go on to name them. You can do a quick Google search about the names of the moons of Jupiter.
They have how many moons does Jupiter have again?
Someone add the names of the moons of Jupiter in the comment section, please. So in 1610, Galileo made this drawing where you can see the different moons of Jupiter. So this drawing by Galileo actually shows how Galileo saw the different moons of Jupiter using his telescope. And they changed. Why did they change position? Say.
Why they change position?
Yeah, the moons of Jupiter. Why do they change?
Jupiter. When
Because
the time
they?
because there is day and night.
Not day and night. Kind of. Why is there day and night? Why? Someone help. Anybody?
Mr. What's the question?
So Galileo, he drew these pictures, right, of Jupiter and its moons, but the moons are in different positions. Why? What do the moons do?
Move around, orbit.
There we go, orbit. Well done. Who said that?
Ahmed Al-Swedi.
Yeah, achievement points for you, Ahmed. Ahmed Saidi. Good, they orbit. You should know that, guys, from your space topic. All right, continuing. So, recently, they made a spacecraft, I think they named it Galileo, and it orbited Jupiter. So we can see the most detailed images of the moons. So it showed that one of the moons called Europa showed that it has like a thin cracked ice surface, as you can see from the picture here. So evidence shows that there might be some salty water underneath the ice. So since 1990, the Hubble Space Telescope has been orbiting the Earth. Anyone know what this is?
This is called
Who remembers from the space topic?
Mr. Star. Constellation.
Excellent. Was that Bilal?
Yes.
me.
Alright, 2 points for Bilal. Well done, Bilal. Constellation. And what is a constellation?
Pattern of stars or something like this.
Excellent. Who was that? Ahmed.
Ahmed Al-Swedi.
Yeah. 4 achievement points. Okay. Continuing. For 25 million light years away from Earth, there's another galaxy. So these are images taken by the Hubble Space Telescope. shows more detail about the 1 trillion stars in the galaxy. Okay, so that was about lenses. Hopefully you enjoyed that. Now, what does refraction mean? Ahmed, please. Swedi.
The change of direction of light is called refraction.
Yeah. Continue, please. Refraction happens.
Happens whenever light travels from one transparent substance to another.
What's transparent?
Substance that light can pass through.
Good. Continue. Continue. It only takes place.
Mister, I will read.
Go on.
It only takes place where two substances meet at their interface. If the light passes through the interface at 90 degrees, it does not change direction.
Okay. What's the interface?
I think when two substances meeting together.
Yes, correct. Good. Okay. So this is the diagram. So we already know our reflection diagram. This is our refraction diagram. So as you can see, the normal is the imaginary dotted line. The angle of incidence is here. The incidence ray is where the light's coming from. This is a glass box. Okay. So as you can see, the light ray, how it's refracted through, and the ray bends away from the normal. So here the incident ray bends towards and goes towards the normal, but when it comes out of the glass box, the ray bends away from the normal, and you'll have your angles here and here. This is a glass box, and they show it to you in this diagram here. So you can see, you can investigate the path of light through this glass block using a ray box, and we can mark the points where it enters and leaves. Okay. Now, right. Let's quickly do these questions. Let me ask some of you. Let's ask Safe, please. Why are lenses needed in cameras, telescopes, and microscopes?
To make the pictures bigger, and to make it clear.
Okay. What does refraction mean?
Refraction. Something whenever light travels from one transparent object to another. This is refraction.
No, it changes something. Changes?
It changes the direction
Of direction of light.
Direction, yes, changes direction. Thank you. Right, so for cameras, lenses are used to give sharp images, telescopes to make distant things.
So we write this in the book?
You should have done it before. This is just a review. You should have done it in your PowerPoint for last lesson. To make small things look bigger, microscopes. So refraction is the bending or change in direction of light as it passes from one medium to another. Okay. Now, let's have a look here. It's loading. Get that. So there are things called converging lenses, as you can see here. So it actually bends. It bends. So lenses are curved pieces of glass or other transparent materials. So as you can see in diagram E, this is called a converging lens because it makes the rays of light come together, and it's easier to think about how lenses work if you think of it being made up of lots of separate glass. So if you have a look here, the light rays, they come at different parts or go through different parts of the lens, the converging lens, and you can see that they all bend to the same direction, which is called a focal point, and then they bend away again. Okay, so that was just a quick review, guys. Can everyone now go to camera and eyes? That's today's lesson. Camera and eyes. Everyone done? Give me a thumbs up when you're on the next page. In the comment section. Everyone's mic should be off. I don't know why I can hear people.
hello, mister. How are you?
Who's that?
فيصل الحبابي.
Okay. Everyone done? Just give me a thumbs up in the comment section. Okay, guys, so just before we move on to that, I just quickly want to show you a video about refraction just before we move on. Can everyone see that? Yeah, everyone see the video? Can everyone put them mics on mute, please? Hear lots of sound. Mics on mute. Okay. So this is an experiment, so let's have a look. So to measure the angles, we need a protractor. We mentioned. So we need a power pack. So we need a power pack, a ray box, a ruler, a glass block, pencil, and a protractor. A rubber and a blank piece of paper. It also works with a material called perspex. So we're going to draw a ray diagram to show the refraction of light through a glass block. So we want to put our block flat down on our page. And we'll draw around it.
Mister, I bring protector, the paper and these things to measure.
No, not now, not now. We'll do it another time. So you'll mark the midpoint, okay, between the line, so halfway through. So we're going to use a protractor to mark 90 degrees to the edge of the box. So this line is called what? From our diagram. We should know. What's this line called? Somebody. Everyone's gone quiet. What is this called, this line?
I
Normal.
think which
I
line?
think-
Normal. Thank you very much. Normal. The normal line. Good. So the normal is just from the outside to halfway through. You don't need to draw it all the way down. You put the glass block back on the page. So as you can see, our ray light is shining the light through the glass block. So we need to make sure we know where the ray lines went. So it's very hard to put a ruler in and draw it now. So we'll just put an X there to plot where the lines are. So we can join them up later. So we shine the ray of light directly where the normal is. Okay, directly where it hits the glass block at the normal. So at the point where the normal line hits the glass block, so if you can see carefully, it looks like the ray of light is going in its direction, yeah? But it can't be, because look, coming out, there's a line going here. So this should go where? It's not the same as where it's entering. So it's emerging at this point. It's coming out at this point. We're going to plot where the ray of light is going. And we mark a point where the ray of light comes out of the glass block. Now our final step is all we need to do is start drawing our lines. So the ray of light came from this point, and we're going to draw an arrow to show the direction of light. And the ray of light emerged from here. And again, you'll draw an arrow here to show the direction of the ray of light. So in the block, the ray of light must have traveled through this path. Yeah? So as you can see, the ray of light has not traveled in a straight line, because it's been refracted by the glass block. Okay, so this angle is called what, someone? Angle of?
Refraction.
Nope.
Of reflection.
Incident.
This one, this incidence. Who said that?
Me.
Me. I don't know.
Me. Kala.
Okay, and this one then. If this one is angle of incidence, what's this?
Angle of reflection.
No, we're not studying reflection.
Refraction.
Incident ray.
Refraction, exactly. Angle of refraction. Good.
Refraction.
So that's why he's written an I here and an R there. So we can mark a second normal line at this point. Okay. We can try and do that at some point, but you may need to buy some glass blocks and array box. Maybe we can use a torch or something, and maybe a glass block. I don't know where you'd find a glass block from. Right, guys, let me just stop the recording for this.